One of the most devastating celestial impacts in history occurred 65 million years ago, when an asteroid with a diameter of 6 miles slammed into what is now the Yucatan Peninsula, wiping out most plant and animal species on Earth, including the dinosaurs. It has, however, been predicted that the next asteroid of substantial size to potentially hit Earth is asteroid 2005 ED224. An asteroid with a height of 164 feet, 50 meters, is predicted to approach Earth on March 11, 2023, with about 1 in 500,000 chance of causing an impact. However, in an attempt to defend Earth from the potential asteroid and comet hazards, NASA recently launched the world's first planetary defense test mission.
A spacecraft intentionally crashed into an asteroid on September 26th.
It used a spacecraft to hit an asteroid.
3, 2, 1.
Oh, wow.
By purposely colliding with an asteroid 7 million miles, 11 million kilometers, from Earth to see how possible it is to change a space rock's orbit should we ever need to deflect any future asteroid strikes headed our way. To see what happened and discover if it's really possible to defend Earth from such a catastrophe, join us as we explore NASA's latest asteroid redirection experiment. Astronomy is a wonderful detective story where we use our powerful telescopes to look far out into the universe and sometimes see things that are unbelievably small, but at such a distance that we can't easily approach them. Our solar system orbits around the sun, along with millions of other cosmic bodies like asteroids and comets. Most of these cosmic bodies are too small to pose a threat, but some can be a cause for major concern. Asteroids are space rocks that orbit the sun. Most asteroids are found orbiting in the asteroid belt between Mars and Jupiter, but occasionally, some get nudged out of their orbits into Earth's orbit. These asteroids are called near-Earth objects, NEOs. A near-Earth object is considered dangerous when it comes within 4.6 million miles, 7.4 million kilometers, of Earth, and if it is at least 460 feet in diameter. A space object this size could cause severe damage to a city if it were to crash into Earth. Other larger objects could have global effects, even causing mass extinctions. NASA's latest planetary defense project could present a potential breakthrough in civil space technology. Previously, all attempts to destroy or redirect an asteroid or comet required remote deployment of a nuclear missile. However, this test mission, dubbed DART, deployed the first intentional kinetic impactor on a celestial object. The Double Asteroid Redirection Test, or DART, is a kinetic impactor designed to effectively and successfully target both asteroids and comets, and for the first time in history, safely redirect them from their current course, thereby preventing Earth from being struck by potentially hazardous asteroids and comets. This project is considered the first step toward interplanetary propulsion, which bodes well for future space exploration. In what looks like a cross between a Hollywood blockbuster and an everyday event, NASA's DART successfully impacted an asteroid moonlet, Dimorphos, a small body just 530 feet in diameter, on September 26, 2022 at 7:14 p.m. EDT, nearly after 10 months of flying in space. According to NASA, Dimorphos orbits a much larger asteroid called Didymos, which is 2,560 feet in diameter. Detailed images of the impact of the planetary defense test were captured by both the James Webb Space Telescope and the Hubble Space Telescope, and a tiny satellite called LICIACube that was deployed from DART, marking the first time both telescopes have observed the same celestial object together. Zipping through space at approximately 14,000 miles per hour, NASA's DART spacecraft slammed into the surface of the asteroid at a hypersonic speed, causing a crater roughly 130 feet in diameter. The James Webb Telescope took observation of the impact location before the collision took place, and then several more over the next few hours using its near-infrared camera, capturing a total of 10 images over a time frame of roughly 5 hours. While the $10 billion James Webb Space Telescope is impressive as the latest and most powerful space observatory the world has ever seen, It was, however, not designed for the unique requirements of capturing fast-moving objects like an asteroid. However, the Webb team overcame the challenges, and NASA explains that the teams performed additional work in the weeks leading up to the impact to enable and test a method of tracking asteroids moving over 3 times faster than the original speed limit set for the Webb. Hubble also captured the DART impact, first just ahead of the collision, and then again 15 minutes after the satellite impacted Dimorphos. The legendary observatory captured the impact using its wide-field Camera 3 and showed it in visible light. In total, Hubble captured 45 images of the event. Stitched together, the pictures show wispy plumes of material suddenly spiking out of Dimorphos after the DART crash, with the asteroid becoming 3 times as bright for 8 hours following the event despite the modest mass of buggy-sized spacecraft. LICIACube, a small Italian cub seat aboard the Hayabusa 2 spacecraft, which was released 11 days before the impact, also observed the action from a distance of several hundred miles, releasing several images to Earth. LICIACube is part of the DART mission, which carries out observational analysis of the Didymos asteroid binary system after the impact on Dimorphos. A statement made by Dr. Thomas Acker of Northern Arizona University in Flagstaff, Arizona said, "I have nothing but tremendous admiration from the Webb mission operations folks that made this a reality, and I'm tremendously happy that this has come to fruition." According to NASA, the observational collaboration will reveal new information about the battered asteroid, although it's been said that neither asteroid poses a threat to Earth. However, the James Webb Space Telescope and the Hubble Space Telescope could provide insights to astronomers about the dynamics of asteroid collisions in our galaxy and how these things are affected by other celestial bodies that come into play. NASA Administrator Bill Nelson said in a NASA statement, "Webb and Hubble show what we've always known to be true. At NASA, we learn more when we work together." The double asteroid impact event was a success in the sense that it successfully changed the course of Dimorphos. However, scientists will be looking closely at data from all of the observatories to determine how much of an effect the DART collision actually made on the asteroid. And as a result, the Hubble telescope is being tasked with observing the Didymos-Dimorphos system 10 more times over the next weeks. That will show how the ejecta cloud expands and fades over time, and will help astronomers paint a more complete picture of the aftermath of the impact. DART's success provides a significant addition to the essential toolbox we must have to protect Earth from a devastating impact by an asteroid, said NASA's Planetary Defense Officer Lindley Johnson. This demonstrates we are no longer powerless to prevent this type of natural disaster. Would you really agree with this? Are we really capable to defend Earth if needed? Share your thoughts in the comments below. And if you want to see NASA breaking the laws of physics, you'll want to see this video here. Stay up to date with all the latest findings in the galaxy at space-news.co, and make sure to subscribe for all the latest videos from Space News.